Hello. So far we've done this whole thing in bits and pieces. Let's try it to be a little bit more, let's try to put it all together. So here is what one significance test will look like. This is our paramedic example. We start with a null hypothesis that the mean was 6.7, and our alternative hypothesis, the thing we wanted to prove, was that the mean response time is less than 6.7. Now over here we have to explain what our mu is. Mu is the average mean time for the hospital after the encouragement. Remember the chief or somebody told the paramedics to increase their response time, and we want to see if that actually did something. Then once we have our hypotheses, we look at the conditions. The data comes from a random sample. That's condition number one. We can assume that the data are independent if there are more than 4,000 calls. That's your population is at least 10 times as big as your sample. That's done. The central limit theorem tells us that the data are approximately normal because there are more than 30 calls. So we just checked off all three conditions that we need. Now we can look at the calculations. What's the probability our x-bar is less than 6.7? Well, the probability our z-score is less than 6.48 minus that over our standard error, which was negative 2.2, which gives us 0.014. Now that I get a p-value of 0.014, we just do our interpretation like we did in the last video, and since p-value is below our alpha level 0.05, we reject the null hypothesis, and we have evidence that the paramedics have increased their response time. All right, now that's one whole significance test. Let's see if we can do some more together.